Let us continue dipole moment. In the dipole moment, we will take methane. We will take methane. Here, central atom is carbon. Its valence shell contains 4 electrons. Its valence shell contains 4 electrons. These 4 electrons making bond with the hydrogen atoms. This bond is rear to the plane. This bond is towards us. Okay. In the methane, carbon atom is not having any lone pairs. Surrounding atoms are same. Therefore, it is symmetric. Symmetric. So dipole moment is equal to 0. Therefore, this molecule is non-polar molecule. The molecule is non-polar molecule, we can say. Sir. Next, we will take we will replace one of the hydrogen by Cl. So we will get methyl chloride. One of the hydrogen we are replacing by Cl. So we got methyl chloride. That methyl chloride dipole moment we will see. Here hydrogen atoms. Okay. Now this carbon electronegativity is 2.5. Chlorine electronegativity is 3. That therefore dipole moment is like this. So this molecule is having dipole moment. This molecule is having dipole moment, that is 1.86 dB. 1.86 dB. Therefore, this molecule is a polar molecule. The molecule is polar molecule. Why this molecule is having dipole moment? In the sense, surrounding atoms are not similar. Surrounding atoms are not similar. Therefore, this molecule is not symmetric, so that this molecule is having dipole moment. So this molecule is polar molecule and this bond is polar bond. Okay. Next, another hydrogen is replaced by Cl. So we will get CH2Cl2. CH2Cl2. So here Cl we can write, here hydrogen, here Cl. For this dipole moment is like this. For this dipole moment is like this. Okay. So now we have to see the dipole moment. What is the dipole moment of this molecule? That we have to see. Now whether the dipole moment of this molecule is greater than this one or lesser than this one. Okay. So whether the dipole moment is 0 or non-zero. Okay. Now the dipole moment of this molecule is 0 or non-zero, we have to see. So now we will take a here bond angle is how much? In the sense 109 degree 28 minutes. Everywhere bond angle is 109 degree 28 minutes. Therefore only it is symmetric. Now so here bond angle is 109 degree 28 minutes. What about angle between these two chlorine atoms? What is the angle between these two chlorine atoms? What is the angle between this CH and CCl bond? What is the angle between these two CH bonds? That we have to see. Sir. Before that, here we will see the bond angle. Bond angle between Cl and H. Bond angle between CH bond pairs. That we will see. Here bond angle between CCl and CH. And another bond angle is between CH bond pairs. How it will be there? Here in this methane, everywhere. In this methane, bond angle everywhere 109 degree 28 minutes. What about bond angle in CH3Cl? Whether 109 degree 28 minutes are different. That we have to see. Sir. For which we will take this CH3Cl. This CH3Cl will take like this. Now we will assume everywhere bond angle is 109 degree 28 minutes, like this we will assume. Okay, we are assuming that the bond angle is 109 degree 28 minutes, we will assume. Sir. What is the hybridization of this carbon? That we will see. This carbon is having 4 sigma bonds. 4 sigma bonds means sp3 hybridization. This carbon is not having any lone pair, therefore the shape is tetrahedral. So we have assumed the bond angle is 109 degree 28 minutes, but surrounding atoms are different, therefore we have to check this value. Sir. Now here how this value will be there, that we will see. First we will take CCl bond and CH bond we will take. Okay. Now it is a valence shell of carbon. It is a valence shell of carbon. Carbon valence shell we have considered as a sphere. It is a nucleus. Okay, it is carbon. This it is a nucleus. Its valence shell we have considered. Now CCl bond we will take. Now we will take a CCl bond. It is CCl bond pair. It is a CH bond pair. CH bond pair. And other two CH bond pairs we will take. CH bond pairs we have taken. Okay. Now, for this carbon, electronegativity is how much in the sense? 2.5. It is 3. Therefore, Cl is having higher electronegativity. Cl is having higher electronegativity. So that since Cl is having higher electronegativity, the bond pair is concentrated highly near Cl. So for this bond pair is concentrated highly near Cl. Sir, here it is 2.1. CH bond pair in the sense the bond pair here electronegativity difference if you see small only. Sorry, okay. Here how the electronegativity difference is there means here electronegativity difference is equal to how much in the sense 0.4. Here electronegativity difference is equal to how much in the sense 0.5. So electronegativity difference here 0.4, here electronegativity difference 0.5 in the sense electronegativity difference much is not much difference. Electronegativity difference is not having much value. Difference is not much. Sir. Therefore, we will need not consider this electronegativity. We need not consider here. For this case, we need not consider electronegativity. Now, we will take a size of this chlorine. Size of chlorine is high. Why size of chlorine is high in the sense for chlorine, what is the electronic configuration in the sense 1s2, 2s2, 2p6, 3s2, 3p5. Okay, so 3 shells are there. Chlorine is having 3 shells, but hydrogen is having only 1 shell. Hydrogen in the sense only 1 shell. So chlorine size is high, whereas hydrogen size is low. Hydrogen size is low. Therefore, if you take angle everywhere 109 degree 28 minutes, if you take angle 109 degree 28 minutes everywhere, then what will happen in the sense? Here we have taken like this. Everywhere if you take angle 109 degree 28 minutes as per assumption, then Cl and H will be closer. H and H will be far away. H and H will be far away. Cl and H will be closer. H and H will be far away. Therefore, here between this chlorine electron cloud and hydrogen electron cloud, repulsion will be high. Between these two, repulsion will be low. Therefore, what happens means here, since repulsion is high, the system is unstable. Therefore, the system, what it will do means the system will reduce this repulsion by doing something, and the system will raise this repulsion by doing something, such that the magnitude of repulsion here the magnitude of repulsion and here the magnitude of repulsion become same. Okay, become same. So what system is doing in the sense system rises this system reduces repulsion here, and system rises the repulsion here, such that at one stage the magnitude of repulsion at this place and at this place remains same. For which what system does means system rises the angle between these two. Okay, so by increasing the angle, here by decreasing the angle. So if angle increases, if angle rises here, automatically repulsion reduces. If angle decreases here, automatically repulsion increases. So at one stage the repulsion magnitude of repulsion here and magnitude of repulsion here remains equal, becomes equal. At that time, system becomes stable. Therefore, the angle between CCl and CH will not be 109 degree 28 minutes. It is greater than 109 degree 28 minutes. Angle between these two CH bond pairs less than 109 degree 28 minutes. Okay. So in the CH3Cl, the angle is not 109 degree 28 minutes. How many angles will be there means two different angles will be there. So in this CH3Cl, how many bond angles? How many bond angles will be there in the sense two different bond angles will be there. Two different bond angles will be there. That is, this is one bond angle, it is another bond angle. This bond angle will be higher, this bond angle will be lower. Okay, like this the CH3Cl will be there. Okay. Next we will talk about this CH2Cl2. Here, how the bond angles will be there in the sense this bond angle will be greater, this bond angle will be lower, this bond angle will be still lower. Therefore, how the bond angle will be there in the sense A greater than B greater than C, like this will be their bond angle. Okay. Therefore, here since here bond angle is high, here bond angle is high, here lesser, here still lesser. Okay. So how the dipole moment is there for this molecule, that we will see. The dipole moment is so and so. The dipole moment is smaller than this. The dipole moment of this molecule is smaller than this. Why the dipole moment here smaller than this one? Because this CCl, this bond angle is smaller than this bond angle. Okay. Now this bond angle is smaller than this bond angle, this bond angle. Therefore, what happens means here the dipole moment is smaller than this one. Here dipole moment is how much in the sense less when compared to this one. Sir, now let us replace one more hydrogen by Cl. So one more hydrogen by Cl will take. So how the dipole moment here is there means it is still less when compared to this, that is 1.03 d. It is having still less when compared to this. Now we will replace this hydrogen by Cl. That hydrogen also will replace by Cl. Now what is the dipole moment of this molecule in the sense 0? So why? Because here all the atoms are chlorine atoms. Here all the surrounding atoms are chlorine atoms. Therefore this molecule is symmetric. This molecule we can say symmetric. All the surrounding atoms are chlorine atoms here. This carbon is having only sigma bonds, 4 sigma bonds. Here no lone pair. Lone pair is not present. Therefore, this CCl4 is symmetric as like CH4. As like CH4, this CCl4 is symmetric. Therefore, this dipole moment is 0. Therefore, it is a non-polar molecule. Okay. This is what means non-polar molecule. Okay. So, if we replace the H by Cl, what happens means here the CH3Cl is having dipole moment. Then onwards, on replacing hydrogen by Cl, dipole moment goes on reducing. When all the hydrogens are replaced by Cl, the dipole moment is 0. It is like this, is sir. Okay. Sorry. Next we will take lone pairs. We'll take the molecule which is having lone pair. Now we'll take SnCl2. This Sn comes under group 4a. Therefore, this valency shell is having 4 electrons. Out of 4 electrons, 2 electrons are bonded, remaining 2 electrons being as a lone pair. Okay, it is SnCl2. In this SnCl2, this SnCl is having dipole moment like this. This bond is having dipole moment like this. What about lone pair? Whether lone pair is having dipole moment or not having dipole moment, that we will see. Lone pair is having dipole moment or not having dipole moment. Sorry. Now, this lone pair is repelled by this bond pair. Okay. Lone pair is repelled by bond pair. Therefore, Due to this, lone pair is moving up, moving up. Lone pair is moving up. Lone pair is moving up in the sense what happens to the how the lone pair density will be there, that we will see. Lone pair density, how it will be there in the sense at this place lone pair density is low. At this place lone pair density is high. Lone pair density. Therefore, this is having dipole moment. That dipole moment is like this. So, lone pair is having dipole moment. That dipole moment is so and so. Here, partial positive pole. Here, partial negative pole. So, lone pair also having dipole moment. So, SnCl2 we will take in SnCl2 how the dipole moment will be there. We'll see. Now, this is having dipole moment. That is mu. This is having dipole moment, that is mu. This magnitude of this dipole moment are equal. Magnitude of these two dipole moments are equal. Due to this SnCl2, due to these two bonds, what is the resultant dipole moment? That we will see. Resultant dipole moment we will take. Now, the resultant dipole moment is like this. It is having mu. Mu in the sense here mu we have given, therefore mu1 we will take. Okay. Now, this lone pair is having dipole moment like this. This dipole moment and this dipole moment need not be same, may or may not be same. Therefore, we do not know. So, we will say this dipole moment is mu2. For these two bonds, resultant dipole moment is mu1. For this lone pair, dipole moment is mu2. Now, what is the net dipole moment? Net dipole moment we cannot say 0 because this resultant dipole moment and the lone pair dipole moment will be equal. How do we say? May not be equal also. Therefore, resultant dipole moment is not equal to 0. So, dipole moment of this molecule is not equal to 0. Therefore, this molecule is what in the sense polar molecule. The molecule is polar molecule. This bond is having dipole moment. Therefore, this bond is what means polar bond. This bond is polar bond. Now, this molecule is symmetric or not symmetric. How do we say? Here, surrounding atoms are same, but the central atom is having lone pair. Here, due to this, this molecule is not symmetric. This molecule is not a symmetric molecule. Okay, this is not a symmetric molecule. Okay, so this molecule. So, if due to lone pair, this molecule is not symmetric. We said, but in some cases, the molecules will have lone pair. Even then, that is symmetric. That is also possible. One example is xenon tetrafluoride. Xenon tetrafluoride is symmetric molecule. Sorry, okay. Now, here SnCl2 bond is polar. The molecule also polar molecule. The molecule is not symmetric because of lone pair present in the tin. That we can say. Next, we will take ammonia. We will take. We are taking ammonia. In ammonia, central atom is nitrogen. This valency shell contains 5 electrons because it is coming under fifth A group. Fifth A group, each electron, these 3 unpaired electrons making bonds with the 3 hydrogen atoms like this. Okay. Now we will see regarding dipole moment. This lone pair is having dipole moment like this. This bond pair is having dipole moment so and so. This bond pair dipole moment towards nitrogen we have to say. Towards nitrogen. Because nitrogen electronegativity is more when compared to hydrogen, therefore like this. So dipole moment will be like this. All the dipole moments projecting towards up only. Okay. Here, what is the bond angle? Bond angle between NH bond pairs is 107 degree. So this molecule is having dipole moment. Dipole moment of this molecule is 1.47 dB. So this molecule is a polar molecule. This bond is a polar bond. The bond is a polar bond because the bond is having dipole moment. Therefore, this bond is polar bond. We can say. Okay. Now, the shape of this molecule is a trigonal pyramid. and this nitrogen is having sp3 hybridization. Okay, now we will take NF3. In the NF3, central atom is nitrogen. This nitrogen valence shell contains 5 electrons. The 5 electrons we have written. This is making bond with fluorine. It is making bond with fluorine. It is making bond with fluorine, and the lone pair is there here. So now how the dipole moment will be there here, that we will see. This fluorine electronegativity 4, nitrogen electronegativity is 3. Therefore, dipole moment will be like this. So dipole moment like this is there. Okay. This lone pair is having dipole moment like this. Now you say, now let us compare NH3 and NF3. In both cases, central atom is nitrogen. Here surrounding atoms are same hydrogen. Here surrounding atoms are same fluorine. But here surrounding atoms is different. Here lone pair is present at the central atom. Here also lone pair present at the central atom. Now, how the dipole moment will be there for this molecule? This molecule dipole moment will be 0 or non-zero. That we will see first. This molecule dipole moment is 0 or non-zero. What is the value? That we will see. Now we will take NF3. NF3 we have taken. This lone pair we have taken. Now, for these three bonds, what is the resultant means exactly down of lone pair. It is a resultant dipole moment. Resultant dipole moment we will take it as mu1. This lone pair dipole moment we will take it as mu2. Now, net dipole moment, if you see, this resultant dipole moment due to these three bonds and lone pair dipole moment may not be equal. Therefore, this molecule is having dipole moment. Since this molecule is having dipole moment, this molecule is polar molecule, we can say. Now, what is this dipole moment? How much in the sense? This having dipole moment, we came to know it. Sir, it is having dipole moment. Okay. So this molecule is polar molecule. The bond is polar bond. We said. What about dipole moment of NF3 when compared to NH3? This dipole moment, NF3 dipole moment, we are comparing with the NH3 dipole moment. Whether they will be equal or not equal. Not equal in the sense which is higher, which is lower, that we have to see. Now, here dipole moment, if we see, all the dipole moments towards up. But here if you see, lone pair dipole moment towards up, but NF dipole moment is towards down. In this case, due to bonds, resultant dipole moment is towards up. But in this case, resultant dipole moment due to bonds towards down. Therefore, this dipole moment will be what when compared to this? No doubt, dipole moment of NF3 is smaller than dipole moment of ammonia, we can say. So dipole moment of NF3 is how much in the sense 0.23 dB. Dipole moment of NF3. Dipole moment of NF3 is how much in the sense 0.23. This dipole moment is smaller than NH3 dipole moment, we can say. Okay. Next we will see. Next molecule we will take. The molecule is water. We are taking molecule water. In the molecule water, central atom is oxygen. Surrounding atoms are what means hydrogen atoms. Okay. This oxygen valence shell, this oxygen group number is 6A. Therefore, this valence shell contains 6 electrons. This valence shell contains 6 electrons, we can say. Oxygen group number is 6A. Therefore, this valence shell contains 6 electrons that we have written. It is making one bond with the hydrogen. It is making one bond with the hydrogen. Here, what is the bond angle in the sense 104.5 degree? Bond angle is 104.5 degree. Sorry. What is the dipole moment? That we will see. Dipole moment in the sense for this dipole moment is towards oxygen, because oxygen electronegativity is more than hydrogen. So dipole moment is like this. Lone pair dipole moment is like this. Lone pair dipole moment is like this. So the net dipole moment, the molecule will have certainly dipole moment. The molecule is having how much dipole moment in the sense 1.85 dB. The molecule is having dipole moment, that is how much in the sense 1.85 dB. Sir, now how this molecule will be there, that we will see. In this molecule, in the sense of water, like this we can say. Now, hydrogen atoms and oxygen atoms both are in one plane. These three atoms are in one plane. Okay, all the three atoms, are in a plane. Are in a plane, we can say. That means both sigma bond pairs are in one plane. Both sigma bond pairs are in a plane. Are in a plane. Okay. Now, how the dipole moment is there for this bond means towards oxygen, because oxygen is more electronegative than hydrogen. Here also like this. Therefore, how the resultant dipole moment will be there due to these bonds. Resultant dipole moment will be like this. Due to these two bonds, resultant dipole moment is towards up. Sir. Now, how lone pairs will be there, that we will see. How the regarding lone pairs we will see. Regarding lone pairs, these two lone pairs present in a plane. These two lone pairs present in a plane, we can say. These two lone pairs present in a plane. These two lone pairs present in one plane, that we can say. Okay. Now, next point we will see. What about lone pairs plane and this bond pairs plane, that we will see. Plane of lone pairs and the plane of bond pairs. Plane of bond pairs will be same or different, that we have to see. Lone pairs plane and bond pairs plane, what is that? That will be same or different. How it will be there means plane of lone pairs and plane of bond pairs will be perpendicular to each other. Okay, how it is there means will be perpendicular to each other. Perpendicular to each other, like that it is present. Perpendicular to each other. Okay, so plane of lone pairs and plane of bond pairs, how it will be there means perpendicular to each other, like this present. Okay, sir. Now, this bond pair, this lone pair dipole moment will be like this. This lone pair dipole moment will be like this. What is the resultant dipole moment? Resultant dipole moment will be like this. Okay, resultant dipole moment. The bond pairs resultant dipole moment towards up, lone pairs resultant dipole moment also towards up. Therefore, this molecule is having dipole moment. That is how much means 1.85 W. Okay, sir. So in water molecule, dipole moment is there. Therefore, water molecule is polar molecule. The bond is what means polar bond. The bond is what means polar bond, we can say. Bond is polar, molecule also polar. Okay. So we can say molecule is polar, bond also polar, we can say. Sorry. Next we will take another molecule. What is that? In the sense OF2 we will take. OF2. In this OF2, what is the central atom? Central atom is oxygen. Surrounding atoms are fluorine. Oxygen comes under 6A group. Therefore, this valence shell is having 6 electrons. Out of 6 electrons, 2 electrons have gone for bonding. Remaining 4 electrons being as lone pair. What about dipole moment here? That we will see. So dipole moment in the sense this bond having dipole moment towards fluorine. Why towards down? In the sense fluorine electronegativity more when compared to oxygen. Therefore, the dipole moment is like this. So due to the bonds, how the dipole moment will be there? How the resultant dipole moment will be there? In the sense that is towards down. The resultant dipole moment is towards down. Okay. Due to the bonds, resultant dipole moment is towards down. Okay. Now we will see due to lone pairs how it will be there, that we will see. Now we will take lone pairs. Oxygen is having 2 lone pairs, we said. Okay. For this dipole moment is like this. Lone pair means dipole moment towards up. Sir. So now we will see this OF2. For this OF2, we have given two lone pairs for the oxygen. Now, what is the resultant dipole moment for lone pairs? For lone pairs, the resultant dipole moment is towards up. Okay. So, for bond pairs, the resultant dipole moment is towards down. For lone pairs, the resultant dipole moment is towards up. So, this resultant dipole moment and this resultant dipole moment may not have same magnitude. Therefore, this molecule is having dipole moment. Therefore, this molecule is called polar molecule, and this bond is called polar bond. The bond is called polar bond, and molecule is called polar molecule. Okay. Let us compare this dipole moment with water. With water, we will compare. So we are comparing the dipole moment of OF2 with water. Okay. Here central atom oxygen, here also central atom oxygen. Surrounding atoms hydrogen, here surrounding atoms fluorine, here surrounding atoms different. Here central atom is having two lone pairs, here also central atom is having two lone pairs. Okay. So what about dipole moment of water and dipole moment of OF2? How it will be there? Will it be having same value or different value? Okay. In water, OH bond is having dipole moment towards oxygen. Okay. Lone pair is towards up. Okay. So now in water, oxygen lone pair towards up. In OF2, oxygen lone pair dipole moment towards up. Regarding these bonds, in water, bonds dipole moment towards oxygen. In OF2, bonds dipole moment towards down. Therefore, here all the dipole moments towards up, but in this case, bonds dipole moment towards down, lone pair dipole moment towards up. Therefore, how the dipole moment will be there in the sense this water dipole moment will be high. Water dipole moment will be high. OF2 dipole moment will be low. Therefore, dipole moment of OF2 is lesser than that of dipole moment of water. So, OF2 is having lesser dipole moment when compared to what in the sense water we can say sun. Why? Because here this bond is having dipole moment towards down, but this bond is having dipole moment towards up. All the dipole moments towards up here. But in this case, OF dipole moment is towards down, lone pair dipole moment is towards up. Therefore, here resultant dipole moment is small when compared to this resultant dipole moment. Sir, now we will take a water and H2S we will take. Now H2S we will take. In H2S, central atom is sulfur, surrounding atoms are hydrogen atoms. This sulfur valence shell, this sulfur comes under group number 6A. Therefore, this valence shell is having 6 electrons present. This valence shell is having 6 electrons. Now this electron is making bond with the hydrogen. This is also making bond with the hydrogen. Okay. So in H2S, how the structure is there, that we got an idea. Sir. Now H2S bond angle we'll see. Bond angle of H2S. Bond angle of H2S is nearly 92 degree. Water if you see that bond angle is 104.5 degree. Sir, in water, oxygen is having two lone pairs. Water and H2S will see surrounding atoms hydrogen in both cases. Here central atom oxygen, here central atom sulfur. Oxygen and sulfur come under same group, oxygen family 6A group. So oxygen is having two lone pairs, sulfur is also having two lone pairs. Therefore, but bond angle, if you see, bond angle of water is high, bond angle of H2S is low. What is the reason? Why bond angle here more when compared to this? Sorry, we will see. Now, oxygen, electronegativity of oxygen is greater than that of electronegativity of hydrogen. Sorry. What about electronegativity of sulfur and hydrogen? Electronegativity of sulfur is greater than electronegativity of hydrogen. Okay. But how the electronegativity of oxygen and sulfur will be there? We'll see electronegativity of oxygen is greater than electronegativity of sulfur. So this is having higher electronegativity than this. Therefore, bond pair, in this case, bond pair is concentrated high towards oxygen. Okay. So in water, In water, this bond pair is concentrated high towards oxygen, in H2S, this bond pair concentrated high towards sulfur, towards sulfur. Now, what about concentration of bond pair near oxygen and near sulfur? That we will see. Concentration of bond pair near oxygen and concentration of bond pair near sulfur. How it will be there? That if we see oxygen is more, sulfur is less, because oxygen electronegativity is higher than sulfur. Therefore, in this case, bond pair repulsion is high, whereas here bond pair repulsion is low, because concentration of bond pair near oxygen is more but near sulfur is less. Therefore, what happens means, since bond pair repulsion is more, bond pairs move far away. But here bond pairs come closer. Therefore, here bond angle is high, here bond angle is low. Sir. So how the bond angle is there in water and H2S, that idea we got. What about dipole moment? How the dipole moment will be there? Sir. Now we said that here this bond is having higher dipole moment when compared to this bond. Okay. So now we will take, it is a dipole moment of this OH bond. This is a dipole moment of this SH bond. How the dipole moment will be there means, a dipole moment of OH bond is greater than that of dipole moment of SH bond. Because for OH bond electronegativity difference is more, for SH bond electronegativity difference is less. Therefore, dipole moment of OH bond is greater than that of dipole moment of SH bond. So that which is having higher dipole moment, which molecule will have higher dipole moment, do you think? So water dipole moment is 1.85 dB, whereas H2S dipole moment is 0.95 dB. Dipole moment of H2S is smaller than that of water. Okay, water is having higher dipole moment than that of H2S, because sulfur electronegativity is smaller than that of oxygen. So only reason is what? Electronegativity of oxygen is greater than that of electronegativity of sulfur. Therefore, water dipole moment is high, H2S dipole moment is low. Like this we can say. So next molecule we will take. Now we will take a benzene. We will take. In benzene we will take. Benzene molecule, in the sense it is having 6 CH bond pairs. The benzene molecule is having 6 CH bond pairs, we can say. And here what will be there means, pi bonding ring will be there. Now let us replace one hydrogen by chlorine. Sir, one hydrogen is replaced by one chlorine. Rest we will write as it is. Okay. So ring we have given, pi bonding ring we have given. This is called what, in the sense? Chlorobenzene. It is called chlorobenzene. Let us replace another hydrogen by chlorine. Let us replace another hydrogen by chlorine. So which hydrogen shall we replace? Shall we replace